Cool.
Okay. Right, so let's give a warm welcome to our next speaker here, Sutu, who's going to be talking about squeezing water from the stone KornShell in 2019.
Good morning. Welcome to this talk. Let me start with a quick question. How many people in this room are C programmers? Raise your hand. C programmers. Do you program in C? So let's start with a C quiz. What does this code do? It prints something. What does it print? Unix. It prints Unix on std out. If you don't understand this code, it's fine. It was the winner of IOCCC competition in 1987. And when it won the competition, it was termed as the best one-liner ever received. It was written by David Korn. Trying to maintain KornShell is like trying to debug this type of code. Very smartly written code, very hand-optimized code, but it's very hard to maintain. So what this talk is about? It's about AT&T KornShell. I won't talk about MKSH or PDKSH, and it will be a very brief status update from new upstream maintenance. That's me and Curtis. And it will be very shallow. I won't take a deep dive in the details. My name is Siteshwar. I work for Red Hat. I maintain Bash and KornShell at Red Hat. I used to be an upstream maintainer of FishShell, and I also contributed to some other projects like Sailfish OS. And currently I'm upstream in KSH. So what is KornShell? It's a very old shell. It used to ship with Unix, and it's very old. Like the first version came out somewhere in the early 80s, and its initial implementation was based on original Bourne shell. So the first question that comes to our mind is, if it's so old, why try to keep it alive? So let's have another quiz. This is a valid bash script, and there's a bug in this script. What's the bug? It should be trivial if you have programmed in bash. Okay. The bug lies inside this assignment. Bash will fork the last command in a separate process, and this variable will be lost. Why I'm showing you this code? Because if you run the exactly same script in KSH, it will work as expected. And it turns out that even though KornShell is slightly older than other shells, it still has a better language specification. It has support for discipline function, namespaces, compound data types, enums. It has better POSIX compliance, and it is still the fastest POSIX shell. Why I say this? Let's look at an example. This is a simple script. It runs a for loop like 10,000 times, and it runs a subshell inside the for loop. Bash takes like 2.9 seconds, G-shell 2.4 seconds, KornShell takes 78 milliseconds. It's so fast, but no one uses it. Why no one uses it? A few months ago, I was writing tests for built-ins, and I came across this bug. And I reported this bug in upstream. And when I reported it, someone responded on this bug report saying that exact same bug was reported 20 years ago to previous maintainers. They never fixed it. Why I'm showing you this bug? Because this is not the only one. There are many such bugs in the code. And I came in the scene somewhere in mid-2017, and this was the situation of KSH upstream back then. Previous developers have left. Code base goes all the way back to the 80s. It has old tooling, no revision control history, no comments in the source code, tricky code, bad test coverage, lots of old bugs. Everything seems wrong about it. How do you deal with it? How do you maintain the unmaintainable? And the answer is very simple. Don't change anything. Because the code is tricky and your test coverage is bad. Every time you attempt to make a bug fix, you will introduce new bugs. So how do you deal with it? Don't change anything. And do only critical bug fixes. And if you care about stability, this approach sort of works in practice, because if you don't change too much code, there's a very less chance there will be regressions. But this approach comes at a cost. It kills your software slowly. So how do you bring upstream to a healthy state? Let's choose some goal and start working towards the goals. Our top priority is that we want to create a modern but backward compatible version of KornShell. We want to make it easier to contribute. We want to improve its tooling. We want better POSIX compliance. KornShell is largely POSIX compliance, but still there are some gaps in its compliance. We want to fill those gaps, and we want better test coverage. In short, we want to bring this code base to 21st century. How do you deal with it? Now let's working towards our goals. Kane Thompson once said that one of my most productive days was throwing away 1,000 lines of code. We took this advice very seriously. We threw away more than 500,000 lines of code. We dropped almost 80% of the code. What did we drop? This is some statistics. The last version of KornShell that came out from Bell Labs had more than 660,000 lines of code. And currently in upstream, we have 137,000 lines of code around. So what did we drop? It turns out that KornShell was not a single package. It was a sub-package of a bigger package called AST. And AST had all these things. And KSH was sort of dependent on these functionalities. It has support for non-POSIX operating systems. It has re-implementation of lots of POSIX functions. It had entire subsystems like VMLOC. It's a memory subsystem. It had its own AST-specific local subsystem. We threw it all of it, like 80%. This was constituting almost 80% of the code, and we just threw it away. We just took out the core subpackage, the subpackage, KSS subpackage out of this code. And we also threw away the old build system. The old build system was a combination of build system called nmake and a feature detection system called if feature exists. The build system was complicated. No one knew how to debug it. Builds were slow. We threw it away and we switched to Meson, and we managed to improve our build times by more than a factor of 30. Old build system used to take more than 5 minutes to build KSH. Right now it builds in 10 seconds. That's a decent improvement. So you are left with 20% of the code. What do you do with it? Start refactoring it. For example, look at this code. Can anyone make some sense out of it? It seems to be doing something strange, but it's doing something very simple. It's doing this. It's checking for paths under /dev directory. We refactored it. So it's checking for paths under /dev, go to /devft, and otherwise, if the path is std in stdr or stdr, and take some action based on it. What you see on the previous slide is apparently it's a micro optimization, and it was useful maybe somewhere in the 80s or maybe early 90s, but we can just rely on compiler optimizations now. We care much more about readability, and this code is much more easier to maintain. So this is another tricky code. KornShell is full of such tricky codes. What about this if condition? What does it do? So the first condition is checking for an attribute, whether an attribute is set, whether either NVL. It's checking if either one of it's checking if either NVLGS or NVRGS attribute is set, but not both. Like the second condition is doing something strange. It will actually fail if both the attributes are set. This is my favorite comment in the source code. This should never happen, guaranteed by design and goat sacrifice. It was actually happening. There was a bug in this code. We had to fix it. Don't rely on goat sacrifices. Always test your code. And we need more developers. If you like to work on crazy problems, try to refactor this code. Our source code is hosted on GitHub, and the name of repository is AST. It's not KSH due to historical regions. We appreciate any patches. We care about stability, so we need better CI. And this is our Travis dashboard. We test every commit on Fedora, OpenSUSE, Ubuntu, Debian, 32-bit Ubuntu, macOS, and all the internal scripts are run through shell check. We also test on FreeBSD. Travis does not support FreeBSD, so we had to set up our own custom CI. And right now it only supports FreeBSD, but I hope we'll be able to add more operating systems there, maybe OpenBSD, NetBSD, and some variant of Solaris in future. How does our test coverage look like? Our test coverage is currently hitting 65%. It's not a great number, I'm not proud of it, but it used to be worse. And in last 1 year, we had added hundreds of new tests. And this number is slowly going up and it will get better in future. We also run some third-party tests. There's a debugger called KSHDB, which had some tests. It's written in KSH, and there's a shell called Yash. It had some set of POSIX tests. We run all these tests in upstream. And Red Hat has hundreds of internal tests for shells, and we execute all of these tests on every upstream build. Currently, these tests are not public. We have some plans to make them public, but there's nothing concrete yet, but maybe in future. And we need more testers. If you want to help us in testing, please do, please help us in testing in upstream build. We appreciate any testing, whether it's manual or if you want to help us in writing unit tests. We have put a strong focus on defects identified by static analysis tools. So we have fixed warnings identified by Clang Analyzer or GCC warnings, and we also run covariety in upstream. This is the covariety defect rate graph. It's slowly going down. Our defect rate used to be about 2 around a year ago, and it's currently around 0.6. And last but not least, we made it simple to try. We are doing builds for RHEL and Fedora in Copper. If you use RHEL and Fedora, you can subscribe to our repositories. If you don't use RHEL and Fedora, if you use OpenSUSE or Ubuntu, you can subscribe to our OBS repositories. Both Copper and OBS repositories are updated on every commit in upstream. And we need more testers. Upstream, there are hundreds of Linux distros and there are different BSDs. We can't deal with every one of them, so we need help from packages. You don't have to be a crazy packager. You have to. It's very easy to build KSH. You have to run these 2 commands and it should be ready. The build should be ready within 10 seconds. This is my last slide, and I'm going to ask a very relevant question. And the question is it too late to make a change? And the answer to this question is really a matter of perspective. It's really up to if you believe in making a change or not. In my previous slides, I showed you a 20-year-old bug. This is the fix for the bug. We fixed it after 20 years. And this shows the attitude of current maintainers. We don't care if a bug is 2 days old or 2 decades old, we just fix it. And we realize that we have taken over a very big problem. It seems like an impossible problem. 30 years old code, no Git history, bad test coverage, tricky code, no comments in the source code. It seems impossible that we'll be able to deal with all these problems. And it seems impossible that we will ever make a release. And it seems impossible that people will start using KSH again. But in reality, when things start happening, impossible slowly becomes possible. Thank you for listening.
So we've got time for one question if anyone wants to ask anything. Then, I'd like to say thank you very much, and we'll resume again in 5 minutes with the next speaker. In some